Now we're moving on to elevators. This one, easier than last one. So I know tension blows everyone out of the water. Elevators is a little bit easier. So our purposes for this, we are going to understand the idea of what is apparent weight, and we're also going to solve some problems. So apparent weight. So when a person is accelerating up or down, usually you will feel either heavier or lighter. Hence why you were talking about elevators, because you're going to be moving up or down. Although your actual weight, so the force of gravity acting upon you, it's going to stay the same. Your apparent weight differs. So what you feel might not be the actual weight that you have. So apparent weight, how heavy you feel, is equal to the normal force. So whenever I ask for the apparent weight, you're solving for the normal force. You can imagine this if you've ever been on a roller coaster. If you're at the top of some hill, you feel lighter, or as you're accelerating downwards, you're going to feel lighter. But when you're at the bottom of a loop, you feel stuck in your chair. It's the same thing. Or one of those crazy rides where you go up on this long tower, you're facing outwards, and then they drop you. You feel much lighter than you actually are. So in an elevator, we can feel one of three things. Either you feel heavier, lighter, or your normal weight, depending on the situation. So let's look at this and see when you feel each of these. So you feel heavier in two situations. You're either going up from rest, or you're going down and coming to a stop. In either case, you're going to feel heavier when you accelerate upwards. So these are the two situations you're accelerating upwards. Feeling lighter, you're doing the opposite. So going down from rest, or you're going up and stopping. So you feel lighter when you're accelerating downwards. You're going to feel normal weight when you're either at rest, or going down at a constant velocity, or going up at a constant velocity. So when your acceleration is 0, that's when you're going to feel normal. So let's do an example here. We've got an 80 kilogram person in an elevator, and they want to go up to the 4th floor. So after pressing the button, they're going to accelerate upwards at 3.2 meters per second squared. We want to know their apparent weight. In order to solve this, let's look at what the free body diagram looks like. So here's a person in the elevator. We have force of gravity downwards, and we're accelerating upwards. So the normal force is going to be larger. So looking at our F net equation, it's the bigger force, normal force, minus the smaller force, Fg. Fg is an equation, F net has an equation. Plug in numbers, we're going to rearrange this and solve for normal force. So because we're accelerating upwards, the normal force should be bigger than Fg, which in this case it is. So the same person is en route to the 4th floor, moving at 2.5 meters per second. What's their apparent weight? So notice you're moving at a constant speed. So my free body diagram, Fg and normal force, these two are equal. So in this case, Fn is equal to Fg. Have the numbers, plug it in, you get an answer. There's our normal force. Third example, same person. Now they've reached the 4th floor and they're going to slow down at 1.5 meters per second squared. So they're accelerating downwards. So looking at a free body diagram, Fg is going to be bigger because we're accelerating down. So therefore F net is the bigger force minus the smaller. We have the numbers, plug those in, solve it. So that is elevators. That's really the only kind of questions you're going to get. You're either accelerating up, down, or have 0 acceleration. So I don't want you memorizing those equations. Students have tried that in the past. I want you to look at your free body diagram, because that will connect to the entirety of the unit instead of memorizing. If you can work on building free body diagrams and making F net equations from the diagram, you should have no problem with this. Elevators are fairly straightforward. Okay, so our next physics incorrectness video, this one comes from Shaun the Sheep, and we actually just watched this one yesterday, didn't we?
Yeah.
Yep, was it pretty funny?
Yes.
Okay, so this clip, let's see what is not possible in this one, or what is incorrect physics. Okay, you ready? Okay, any guesses? You don't know what this one? Oh, that's because this one's a very subtle one. Do you know what subtle means? Subtle means like it's hard to see. Okay, can I show you what doesn't work with this one? I noticed this when we watched it yesterday. So watch what happens when they jump over the fence, okay? Watch the sheep as they go over. See, look, as they jump over, look. You see them come to a stop at the top.
Yeah.
So they jump, but then they stop. They jump. It's like they hover in midair a little bit. Do you see that?
Yeah.
See, look, they jump and there's like stop, and then they go down. Jump, stop, and then go down. But that's not how jumping works, does it?
Yeah.
When you jump, do you stop at the top a little bit? No.
Because I can't jump like,
Yeah.
I have to hold something to stop.
You have to hold something to stop at the top. Yep, just like that. Exactly. But were they holding something?
No.
No. Exactly.
That can't be possible.
No, that can't be possible. So it looks like, oh, when you're up in the air, maybe you slow down a little bit. But that's not what happens.
Yeah.